Suppose we have four different kinds of motion of fluid particles. We have considered the fluid particle to be of this shape. If a fluid particle displaced from one position to another position, it is called linear translation. Linear translation. If a fluid particle deform from this position to this position, it is linearly deformed. The length increased and breadth decreased. This is known as linear deformation. Suppose we have a fluid particle and it undergoes angular deformation like this. Here, our del theta 1, this is known as angular deformation. In this particular case, we have del theta 1. This translation is dx times dx. And in this specific case, we have our shear strain rate. Shear strain is half of dv upon dx plus du upon dy. This is our shear strain. This is our angular deformation, that angle theta. Fourth is our rotation, where suppose we have this same fluid particle which undergoes rotation and form a particle like this. It undergoes the rotation of suppose anticlockwise 45 degree, then it forms like this. Here in this kind of rotation we have our omega to be half of dv upon dx minus du upon dy. This is the rotation, and this is for one dimensional. This omega is set along this axis. If we have to calculate for the all three dimensional rotation, we have to square all of them, add them, and under root the sum to evaluate the resultant rotational velocity. There is something known as vorticity. Vorticity of fluid. Okay, vorticity. So what is vorticity? Vorticity is 2 times omega. Just to remember this. Okay, and omega is this, and of course omega x, omega y, omega z are evaluated for each rotation of through each axis, rotation of each x-axis, y-axis, a rotation about, and z-axis. This is about the motion of the fluid particle. Now we will talk about velocity potential and stream function. So, and the stream function. Functions are generally mapping of input parameters to output parameters, and they are used. The function are used to define the property of the flow. So, firstly, velocity potential. Potential is a scalar function. It is a scalar function of space and time. Means it depends on x, y, z, and time. Shows that shows that the negative derivation of this scalar function, the negative derivation, derivative of this function. Suppose this is our velocity potential function, scalar function, and the negative derivative of this with respect to any direction give velocity in that direction. With respect to any direction gives velocity in that direction. So the property of the velocity potential is such: if I differentiate it with respect to x and I take the negative of it, I get the value of velocity along x-axis. And similarly, okay, this is the velocity potential, and we have our stream function. Stream function is also a scalar function of time and space. Uh, its partial derivative such that its partial derivative with respect to any direction gives velocity component at right angle to this direction. This direction. Suppose we have a stream function, and I take this stream function and I get the partial derivative of stream function with respect to x, and the velocity stream partial derivative of this function with respect to y gives the velocity in right angle to that direction, means this direction, this is minus